f of x equals 3.1x cubed plus 5.7x squared plus 0.3x minus 1.5 for x is greater than or equal to minus 2 and it's less than or equal to 0.9. G of x equals minus 1.3x squared minus 1.3x plus 0.9 for x is greater than or equal to minus 2 and it's less than or equal to 0.9. Right, so we're given some axes. So the first, if we look at the x's, the minimum value is minus 2, which fits in with this domain given here. Maximum value 0.9, which fits in with this domain given here. You can see f of x and g of x have exactly the same domain. And we're lucky enough to have been given minimum and maximum y values that the question wants us to plot the functions over as well. So you can see this minimum value of y here of minus 3 and a maximum of 4. So we've got blank axes. What do we need to do? So part A, sketch y equals f of x on the axes provided. Part B, sketch y equals g of x on the same graph. Part C, solve f of x equals g of x. And part D, solve f of x is greater than g of x. So A, B and C have all been covered in previous videos. Part D is new, but we're going to need A, B and C to solve D anyway. We're going to use the information gathered in those. So it shouldn't be a problem. Just to go straight into f of x is greater than g of x, we'd have to do all of this anyway. So it shouldn't be a problem and it should help to reinforce anyway. So we will begin with part A, sketch y equals f of x on the axes provided. So we need to go to our calculator. Here we're using one of the older Casios. This is one of the older models of the fx-9860s. I'm going to go to menu and I'm going to go to graph. And I've got a nice clear screen now, it's quite handy. I need to type it in. So 3.1x cubed. So 3.1x cubed. To get cubed, I use this little hi-hat here. Little hat. X cubed plus 5.7x squared. X squared plus 0.3x minus 1.5. Okay, I'm going to go to execute and I'm going to go to draw. And I need to get the window right. So you can see it's a kind of cubic, but it's not, I very much doubt that that's the window that we're interested in. So remember, I need this calculator screen to be this exactly. So I need to go Shift V window, which is F3. So Shift F3. And yes, it's definitely, this is sort of a default zoom. So I need x min to be minus 2. The max, which means x max, is 0.9. I'm not going to change the scale, I'm not going to change the dot. So y min is minus 3 and y max is 4. So execute, execute and draw again, F6. And you can see it looks a lot clearer now. So as I was saying, this screen here on the calculator, that screen is exactly this. So I can now transfer this. So it's a cubic with 2 turning points. So I've got one over here and one over here. Looking at the end points, this one's very close to the bottom left of the screen, probably just somewhere around here. Or around here, it's not completely clear, but maybe it drops off about there. The top right again goes just off the screen, probably there, and I can see a minimum point, a local minimum somewhere around the y-axis. It's not completely clear if it's on the axis or not. It's possibly slightly left actually looking at it. It doesn't matter. If you get it basically in the right area, then that's fine. So it's about sort of halfway down, so it's probably somewhere around here. And I've got this local maximum that's probably a bit, say that's halfway from between the axis and the end of the screen. It's probably a bit more than that. And it goes maybe a third, I don't know, somewhere like that. And then I just need to join with a nice smooth curve. So a bit of pen trouble, I'll just go over that. Okay, so that's my f of x. Part B, sketch y equals g of x on the same graph. So for g of x, well, g of x is minus 1.3x squared minus 1.3x plus 0.9. Now I'm going to do it in a different colour because I think it'll help me to get the points across for part D. I just think it's clear anyway. Obviously, if you're doing this in an exam, you won't be permitted to use a different colour. So be aware of that, but it's not the end of the world. So I'm just going to press exit and I'm going to go to y2 and I'm going to type the second one in. So minus 1.3x squared minus 1.3x plus 0.9. Execute and draw, F6, and you can see a sort of negative or upside down quadratic has appeared over this is the initial cubic graph, and here we've got this new quadratic. So we now need to put that on the same graph. I'm going to do mine in green. So I'm interested in these two endpoints and then getting the maximum, local maximum there in the right sort of place. And then I'm just going to join with a nice smooth curve. So the first endpoint's kind of sort of halfway between the x-axis and the end of the screen, so probably somewhere around there. The maximum is sort of probably halfway between that maximum and the y-axis, and it's pretty much level, maybe slightly higher, so I reckon maybe somewhere around there. And the other endpoint is a similar height to that minimum, maybe again slightly higher, and at the end of the screen, so somewhere around there. And I just need to join these with a smoother curve as I can. Something like that. It's not brilliant, it's probably not as curvy as I wanted it to be here, but it would get me full marks. So that is g of x. Okay, so now we've done part A, we've done part B. Now we need to solve f of x equals g of x. So you're saying, when does 3.1x cubed plus 5.7x squared plus 0.3x minus 1.5, when does that equal minus 1.3x squared minus 1.3x plus 0.9? So all of that, the equation is only about x's, so the answer will only be to do with x's. We solved them, but they're equal when we have an intersection. We covered this in previous videos. So it happens here and here, and there's another one here, somewhere around there. So I'm going to find out where those points are. So I'm going to just write them down as points to show a bit of working, but as I say, the actual answer is only going to be x's that you're interested in. Okay, so I need to find the intersection. So where lines cross each other, firstly that is where they're equal, and second they're called intersections. So Shift G solved, F5, I'm looking for the intersection, ISCT. So the first one, it's gone straight there. X is minus 1.6729, Y is minus 0.563. So remember, unless you're told to do otherwise, you should give decimals like this to three significant figures. So x minus 1.67, minus 1.67, and y minus 0.563. 563. Okay. Second one, remember with the Casio you can navigate between them just by pressing the side arrow. So this point over here is at x is minus 1.0, three significant figures, minus 1.03, and y is 0.8555. There's a 3 next to that, so I'm going to put 0.856. Okay, and then I'm going to go across to the third one, and here, so it kind of looked like it was on the x-axis. It's not quite, but x is 0.448, 0.448 and y is 0.0568, so 0.0568. And as I was saying, y, you're not going to use it for the question, but it does sort of, it helps me to show you what I'm thinking, or why I'm doing what I'm doing, hopefully. So as far as we solve f of x equals g of x, I'm only interested in the x values. I'm going to write them all down. So x equals minus 1.67, x equals minus 1.03, and x equals 0.448. 3 answers. I expect you would get 3 marks for that. Okay, part D. Now this is the new bit. So we're solving f of x is greater than g of x, right? So what that means is, so for what values of x does this return higher y values than that? So we know that they return exactly the same y value when x is minus 1.67, minus 1.03, and 0.448. So what I'm going to do, if I can fit it on, I'm just going to bring these lines down. So this is the first intercept. I'm just going to kind of draw a line down, and I'm going to draw that, and I'm going to do the same with the other one. So that was from this line here, this intersection, and I'm going to do the same here. So just here, and I'm going to draw this. And what I'm going to do, I'm going to use this to say which function is on top. So a function is greater, a line, if a line is higher, if one line is higher than the other one for the same x value, then that's giving a greater value. So that function is greater at that point. So if it's higher than it over a range of x values, then it's greater than the other function for that whole range of values. So I'm going to just bring these numbers down. So minus 1.67 was where they're equal. Minus 1.03 is another place where they're equal, and the final place is 0.448. And then in between, so I've got these 4 regions here, and we're just going to answer the question kind of which function as in f of x or g of x is on top. So which function is on top? So now the first region is sort of between the end and the minus 1.67. So in this region here, which is this bit, which function is high? You can clearly see that the green line is above the black line in that area. So that means that g of x is on top. G of x is greater than f of x in this little area here. So I'm just going to write g of x on top there. Now, this second region is between minus 1.67 and minus 1.03. There's a second interval, x interval. So it's this bit here I'm interested in. So you can see all the way through here, the black line is higher than the green line, so that means that f of x is greater in that bit. Then they intersect where they're equal. So then for this next region, so between this intersection and this intersection, you can see that all the way through here, the green line is giving bigger y values for the same x values. So g of x is on top there. And then the final bit on the right, you can see, so that's between here and kind of the end, you can see the black lines above the green line, so that means f of x is greater there. Right, so now once I've got this diagram sorted out, so answering this question should be really easy. I'm basically saying, well, where is f of x greater than g of x? So over what range of x values, or what interval of x values is f of x greater? Well, I can see f of x was greater in this area here, which I can define, well, x is between minus 1.67 and minus 1.03, and it can't be either of those, because we know that when it is those, the functions are exactly equal. I want to know where it's greater than, not where it's greater than or equal. So the first region is minus 1.67 x, 1.03, so it's less than 1.63 and it's greater than 1.67, so that's one of the answers. And the other area, well, it happens to the right here, so I'm tempted to write x is greater than anything greater than 0.448, so 0.448 greater than, but given that we've restricted ourselves to this particular domain, so -2 to 0.9 inclusive, it technically after 0.9 the graph doesn't exist, so we kind of chop it there, so that's got to be your cutoff really, so 0.9 x, so it can go all the way up to 0.9 because when x is 0.9 the black line is above, and it can't go to 0.448, but anything bigger than is okay, because you know that when x is 0.448 they are exactly equal. So that is the answer, and I guess you'd probably get another, definitely 2, potentially even 3 marks for that bit.